Hi everyone, my name is B. Sai Charan. I am from Data Science Department. Today's subject is matrices and calculus. Topic is inversion of symmetric matrices and unsymmetrical fault analysis. This is the today topic. Objectives. Introduction to fault analysis. Fault analysis determines currents and voltage under abnormal conditions. Types of faults. Symmetrical. First one. Symmetrical. All phases equally affected means all phases equally affected. Unsymmetrical. Unequal phase involvement most common. Importance, protection design, equipment rating, system stability. Next. Types of unsymmetrical faults. Single line to ground means SLG, single round to ground. Line to line, L to L means line to line. LLG. What do you mean by LLG? LLG means double line to ground. Double line to ground. What is three? Single line to ground, line to line, and double line to ground. Next, symmetrical components overview. We can see the overview of symmetrical components. Transform unbalanced set. Transform unbalanced set means that is three balanced set. What is that? Positive sequence and negative sequence, zero sequence. Transform unbalanced set means three balanced sets. That three balanced set is first one is positive sequence, negative sequence, and zero sequence. Equation. We can see the equation here. V012 equal to A inverse V ABC comma A set 1 1 1 1 A square A 1 A square comma A equal to e to the power of I e to the power of j 120 degrees. You can see the once again equation V of 0, 1, 2 equal to A inverse V ABC comma A. A equal to 1, 1, 1, 1 A square A 1 A square comma A equal to e to the power of j 120 degrees. Sequence networks. What do you mean by sequence networks? Each sequence has its own independent network. Each sequence have its own independent equation or network. Networks are combined differently for each fault type. Networks are combined to each other and different types of faults. The impedance matrix for each sequence is symmetric. The condition is Zij equal to Zj. In the both the terms Ij is equal to Z. Positive, negative, and zero sequence. In the above slide, we can see three types of sequences. Here, the impedance of matrix is symmetric. That the condition Zij equal to Zji. Next, impedance matrix relates bus voltage and currents. Some given example bus V bus equal to Z bus high bus. Here Z bus is a symmetric in most elements derived from network topology and line impedance. Matrix inversion concept. Inversion means A to the A inverse. needed to find current or voltage vectors. This is the vectors I equal to Z inverse into V. What? I equal to Z inverse V. For large systems, numerical inversion methods are used. In large systems, we can use numerical inversion methods. For system matrices, computation simplified since Z equal to Z power T. Inversion in unsymmetrical fault analysis. Here you can see unsymmetrical fault sequence network equations written as V0, V1 into V2 whole to the power of T equal to Z0, 1, 2, I0, I1, I2 whole to the power of T. We can see here V0, V1, V2 whole to the power of T equal to Z0, 1, 2, I0, 1, 2 whole to the power of T. You can see in the example of bus, V bus equal to Z bus into I bus. Here given bus in the place of 0, 1, 2. We can write in the place of bus 0, 1, 2. Here write in V0, V1, V2 whole to the power of T equal to Z0, 1, 2, I0, 1, 2 whole to the power of T. Okay now. Invert Z0, 1, 2 to find fault currents. Combine sequence currents to obtain phase currents. Phase current 10 I0, I1, I2. Okay. Example of symmetric fault analysis. Symmetric line fault analysis. Symmetric given here. Symmetric Z bus matrix. Z bus equal to matrix 0 0.20, 0 0.05, 0 0.05, 0.25. We can write in this matrix in the form of inversion Z inverse bus inverse form 1 by 0 0.2, 0 0.25, 0 0.5 into 0 0.5 means 0 point whole square. 1 by 0 0.20 means 0 0.2. Next, diagonal 0 0.25 minus of 0 0.05 into 0 0.05 means 0 0.05 whole square. Here write in the form of matrix 0 0.25 minus 0 0.05 minus 0 0.05, 0 0.2. Minus of 0 0.05 means 0 0.05 minus 0 0.05. Here also same. We can conclude that inversion of symmetric matrices plays a vital role in fault analysis. Okay. Inversion of symmetric matrices plays a vital role in what? Fault analysis. Unsymmetrical fault analysis release and solving sequence problem solving unsymmetrical fault analysis. Second point. This is third point. Using matrix symmetry, faster, more stable and accurate computations. These points used to solve symmetric matrix and unsymmetric matrix. Using matrix symmetric means faster, more stable and accurate computations. Forms the foundation for digital fault analysis and power system stimulators. We can see here symmetric matrix reduce computational load by 50%. Method is most efficient for large positive definite matrices. Accurate inversion yields precise fault currents and voltage. Okay, thank you.